Particles P and Q of masses 10 kilograms and 8 kilograms are attached to the ends of a light, inextensible string. The string passes over a light, smooth, fixed pulley, and the masses are hung with the string taut. Now, these modelling assumptions, like inextensible string, light string, smooth, fixed pulley, and so on, mean that the tension will be the same throughout the string, and that when the particles start to move, they will accelerate at the same rate. The mass P is 2 meters above a horizontal surface. We'll come on to that shortly. The system is released from rest. We want to find the acceleration of the system and the tension in the string, and those two things can be done first, and we'll worry about C and D in a moment. So let's look at A. And before we do that, we know that the weight here would be 10G. The weight here would be 8G. There'll be a tension force here and a tension force here, and of course those are the same as discussed because of the light inextensible string and the light smooth fixed pulley. This mass is clearly greater, so the system will start to accelerate in this direction. P going downwards, Q going upwards. So if we just look at P, the resultant force here is 10G minus T. So 10G minus T would be equal to 10A. That's just F equals ma. Could call that equation 1. If we then look at Q, the resultant force is T minus 8G, so we've got T minus 8G is equal to 8A. That's F equals ma. Now, if we add those two, the T will cancel out. We've got a minus T here and a plus T here. So if we add 1 and 2, so I'm going to equation 1 and 2, I'm going to add them. 10G minus 8G, that gives us 2G, equals 18A. And so A is going to be 2G divided by 18, or G divided by 9 meters per second squared. Now if we substitute that into 2, so we're now on to part B of the question, if we substitute that into part 2, or equation 2, we've got T minus 8G equals 8G over 9. So T is going to be 8G plus 8G over 9. Well, 8G is 72G over 9 plus 8G over 9. So T is going to be 80G divided by 9 newtons. And I'd probably leave it like that. We could cancel it by making G equal 9.8. The force on the pulley. Well, if we now think about string acting, or the force in a string acting in both directions. So if we look at the pulley, we must have T pulling down. So on the pulley you've got 2T, so it must be 2T pulling up. So the force on the pulley is just going to be 2T, which is 160 G over 9 newtons. Finally, the time taken for P to reach the horizontal surface. Well, we know that A is this. Now, it was released from rest. Constant acceleration, so we can use the Suvat equations. We know the distance is 2. We know U is 0. A, well, we know that A is G over 9. And T is what we're trying to find. So we're going to use S is UT plus a half AT squared. So 2 is going to be, this bit disappears because U is 0. And if A is G over 9, a half of that would be G over 18. So T squared, rearranging that, 18 comes up here, so it's 36 over G. And we probably should calculate this one. So 36 divided by 9.8 is that, well, that's t squared, and then we'll square root that answer. So that gives us t equals 1.92 seconds.